Space, the final frontier, the ever-expanding vastness of the universe, measured in light years on account of its sheer size. Even the Enterprise and Voyager from Star Trek never made it out of the Milky Way. Our universe contains an infinite number of huge galaxies which in turn encompass billions of stars, some larger than the Sun. The size of our marginally small galaxy alone is over 100,000 light-years across. These massive galaxies must have an extremely strong force of gravity holding them together. But what is it? How do galaxies form, and what is the pull which makes it possible to form galaxies, stars, and even planets? In order to find out how galaxies are formed, we need to journey back in time to the beginning of the universe. The universe started as an infinitely small and dense point called a singularity. Then that singularity exploded in what scientists call the Big Bang. Soon after the Big Bang, matter fought its opposite, antimatter, to determine which would form the objects in the universe. In the end, matter won, and the remaining particles created all the matter in the universe. 200 billion years after the Big Bang, clouds of hydrogen and helium began to build up and created the first stars. These stars were exceedingly larger than our Sun, which I learned in a National Geographic article. These stars were brighter than our Sun, but burned through their energy faster. These massive stars went supernova and created the first black holes, which would later help in the formation of galaxies. We know that galaxies couldn't have formed at the time of the Big Bang, for there were two other forces awakened in that initial blast: dark matter and dark energy. Galaxies, stars, and planets may be what we associate the universe with, but all around us there are forces we cannot see or even hope to explain today. These forces, dark matter and dark energy, are extremely important in the life cycle of our universe. According to the Visual Encyclopedia of Space, dark matter is invisible matter that pulls on all objects in the universe. Dark energy is just the opposite. It pushes outward and is the cause of the universe's accelerating expansion. Out of the entire universe, visible matter that we can see only makes up about 4% of what is really there. Dark matter takes up 23%, and dark energy is the remaining 72%. While we cannot see dark matter or dark energy, astronomers know they exist because of their effect on visible matter, making one galaxy appear as two. An example of this is that the Milky Way is spinning fast enough that it would fly apart if it only had the gravitational pull of the visible matter it contained. This meant that there was another invisible force keeping the galaxy together, so astronomers called it dark matter. Talking to Professor McLeod at Wellesley College, I learned that dark matter is necessary to keep the Milky Way and other spiral galaxies from falling apart. Each galaxy has an invisible halo of dark matter surrounding them. This halo extends maybe thousands of light years from the edge of the galaxy. Initially, scientists thought that after the Big Bang, eventually the universe would slow down and stop expanding. From my interview with Talia at the Museum of Science, I learned that more recently, astronomers have discovered that the universe was actually speeding up and expanding faster and faster. This phenomenon is caused by dark energy, which overpowers the gravity of dark matter. Now we know one player in the formation of galaxies, but even when we compensate for the gravitational pull of the dark matter, there's not enough gravity to hold large galaxies together, which means there's something else there. Something just as strange and unknown. These are the invisible, light-sucking monsters of the universe. Black holes used to be thought of as fiction. Even Einstein thought they were too strange to exist, according to the Nova film Monster of the Milky Way. Black holes are made after the collapse of stars 10 to 15 times as massive as the Sun. When a star that size dies, it explodes in a supernova and leaves behind a burned-out stellar remnant called the neutron star. If the neutron star is dense enough, it will collapse in on itself and becomes a black hole. In this black hole, the force of gravity is so strong that not even light can escape, and therefore the surface of the black hole is called the event horizon. Unlike many people think, black holes are not flat but are spherical. Since the gravity is so strong, it's currently impossible to travel inside a black hole. But scientists have some hypotheses about what the inside of a black hole is like. Past the event horizon, there is the inner horizon. The inner horizon is where light and energy is trapped inside the black hole. The blinding flash of light it gives off will vaporize you. Anything that gets too close to a black hole will get sucked in and disappear. Even light is not immune to the black hole's immense gravity. When a black hole feasts, matter enters the black hole in a whirlpool. Sometimes it goes in too fast, which makes the black hole spit energy back out into space. The beam shot out is pure energy and is called a quasar. This is another way astronomers can tell there is a supermassive black hole in the center of a galaxy. The energy shot out by the quasar can blast away dust and gas from the galaxy, leaving a blank space. The black hole in the center of the Milky Way has currently been peaceful and has not been feasting. That means that there have not been any quasar activity, but there could be some in the far future, as pictured here. Black holes, as well as dark matter, are extremely important in the formation of galaxies. But what does having a black hole in the center of our galaxy mean for its life cycle? For hundreds of years, the center of our galaxy was unknown to us and hidden by clouds of dust and gas. Astronomers can't use visual light telescopes because interstellar dust blocks light from more distant parts of the galaxy like our solar system. So instead, they use radio waves and infrared radiation, which are longer to penetrate the dust. Since black holes are invisible, they use the movements of the stars around it to determine if there's a black hole in that area. The astronomers noticed that the stars in the galactic center were moving 10 million miles per hour and making dramatic hairpin turns around a single point in space. They concluded that this was the black hole. I learned from the Gale Encyclopedia of Science that the black hole in the center of our galaxy is called Sagittarius A, which is named after its location in the constellation Sagittarius. By looking at the energy and radio signals from other galaxies, astronomers concluded that every major galaxy had a black hole in its center. After new research, astronomers concluded that the black hole is actually limiting the size that any galaxy can reach because of the way the energy from its quasar blasts away dust and gas, therefore preventing new star formation. Now galaxies are able to form, but why and how do they create gorgeous spirals and ellipticals, not just irregular galaxies? We might think that our Milky Way is unique, but if we look farther into space, we will see common shapes among most galaxies. There are four main galaxy shapes: spirals, barred spirals, ellipticals, and irregular galaxies. The Milky Way is a barred spiral. The first galaxies most likely formed when large black holes gathered enough dust and gas to be pulled into a shape and start revolving around it. Larger galaxies formed when these infant galaxies collided and the center black holes merged. When galaxies first form, they are spherical and have no identifiable shape. Then, as the dust, gas, and stars begin to revolve around the central black hole, the galaxy starts to spin. It is this spinning motion that makes the galaxy flatten out into a disk and then a spiral. It takes billions of years for the original clumpy, disorganized galaxies to transform into the ones we see today. Irregular galaxies are a little different. They almost always only form after galaxies collide. All galaxies want to form into spirals, and they mostly do without help. The deciding factor in a galaxy's shape is not how it formed, but its experiences and interactions with other galaxies. Now you have a more complete understanding as to how galaxies are formed and what holds them together. The first baby galaxy formed millions of years ago when the black hole of a massive star pulled in surrounding interstellar dust and gas. As the miniature galaxy gets bigger and starts to spin, dark matter becomes a major force in holding it together. The spinning motion then makes the spherical baby galaxy flatten out and form a spiral. Other types of galaxies are formed when galaxies collide. Our knowledge of galaxy formation and our galaxy's past is important in our future. Without knowing what's in the center of our galaxy or how it was formed, we couldn't predict what the future could hold for the Milky Way. Our galaxy's black hole might become a quasar and blast our solar system and the surrounding clouds out of the galaxy. By observing what happens when galaxies collide, we can predict what will happen when the Milky Way and Andromeda eventually meet. It will be the formation of a new galaxy. The past helps us understand the future. In conclusion, the Milky Way is just a tiny speck in the rapidly expanding cosmos. Millions and millions of other galaxies are out there besides our own. If we can learn more about them, we can learn more about our galaxy. We must be prepared for what the future may or may not be, and the only way to do that is to explore today.